and the ones in red are the ones I got wrong.
Okay.
2/3 of my final answer are correct. I
Okay.
know that for sure. I know that for sure, and it's not because I did more fake division.
Andrew, how are you doing?
Yeah.
Good.
See,
All right.
it was very
All right,
nice.
well, why don't we go ahead and get started then? Because there probably were some questions on the homework set. And these two problems we're going to talk about tonight now, 17 and 23, are both standard maximization problems. Is that the ones you want to?
We should just go for number 10 at the very end, or like,
Or number
instead
10.
of this, because I got a negative number in the right
Oh,
column,
no.
and I
Okay.
didn't multiply it.
All right, well, we could do that, or we could do that separately in my office or something like that. Okay. Let's actually do 17 and 23 real quick. Here's the deal. These guys being standard maximization problems, they're kind of the basic kind of problem that we build on for the next couple days, okay? So I want to make sure that we know how to do these guys. So let's take a look at number 17. And I'll share this spreadsheet with you guys, but let's just call this, we'll call this problem 17 on page 158. Okay, that'll be the name of our spreadsheet here. All right, so we're maximizing this function here, and it's a big mess. But we already can kind of figure out the patterns of these things, right? There's going to be an x1. How many variables are there? It goes all the way to 5. x2, x3, x4, x5. All right. Now, 1, 2, 3, 4. I can tell already there's going to be 4 slack variables. So I'm going to go ahead and just start building this table out a little bit here. Because there's going to be 1 slack variable for each of the inequalities, right? Okay, so now, all right, so the matrix is, the tableau is going to be what? 16, 19, 23, 15, 21, 1. And then these things are all zeros. And then the last one is 42,000. Right? All right. And let's do the same thing for the next one. 15, 10, 19, 23, 10, 0, 1. And then zero these out all the way over to here to 25,000. And then we're going to go do this next row, which is 9, 16, 14, 12, 11, 0, 0, 1, 0, 0, 23,000. Is that right?
Yeah.
Yeah. All right. And then the next one is 18, 20, oh wait, I didn't sign out. How that happened? Sign back in.
Yeah, it booted me off my computer.
What's that's all about?
Right.
Alright. Am I back in? Sign into your account in another tab. I wonder why it's doing that. Leave site. Oh, well, fine. I don't really have any choice, do I? Cancel. Here, let me cut these guys just in case. Copy. Alright, so apparently it wants me to log out. Let's just close all this up and try this again. And this is the one I want. Alright. Alright, 18, 20, 15, 17, 19, 0, 0, 0, 1, 0, 36,000. And then, alright, so on that objective function, we have to pull everything over to the other side, leaving what the z is. So it's negative 37, 34, I'm sorry, negative 34, negative 36, negative 30, negative 35, 0, 0, 0, 0, and 1, and 0. Alright, so if I made no mistakes putting all that in there, that is our initial tableau. And I'm going to shrink this down a little bit, just so it all fits on the screen at one time. Okay? Even though I know it makes it a little smaller and harder to read. Alright, so what is our first step in solving one of these standard maximization problems?
Most negative.
Find the column that has the most negative indicator variable. And are we in agreement it's this one? Alright, so it's going to be someplace in this column. I'll highlight that just to make it a little clearer. Alright, so this is the column we use then when we're making those quotients. Let's just stick those quotients over here someplace. Quotients. That means it's going to be this one divided by this one. Alright, Now, there's all kinds of if you divide it by 0 and if you divide it by a negative number and all that kind of stuff, but none of that happened here. So we find the smallest one of those, and it's this one, right? So this is the row with the smallest quotient, and we already knew it was the column, so we know it's got to be this one. This is our pivot. All right, so what are we going to do here? How are we going to compute our rotation then? All right, so to get row 1. Row 1 will be 15 times row 1 minus 16 times row 2 becomes the new row 1. Is that what you guys did? Yeah, okay. Equals 15 times row 1 minus 16 times row 2. Alright? Alright, we didn't end up with a negative number over here, so we're good. Okay, row 2 is just the pivot row, so it's just equal to where it was before. Alright, row 3. How about 15 times row 3 minus 9 times row 2 becomes the new row 3. Don't get me wrong, there's probably ways we could have factored this a little bit easier, right? I mean, probably it could have been 5 times that and so on, but, or should we do it that way? Yeah, let's keep it this way. Equals 15 times row 3 minus 9 times row 2 becomes the new row 3. And notice we did get a 0 there. And notice we didn't get a negative number in the rightmost column. So we're so far so good. Row 4. How about it is 15 times row 2 minus, no wait, 15 times row 4 minus 18 times row 2 becomes the new row 4. Equals, are you noticing that there's a pattern there? 15 times row 4 minus 18 times row 2. Make sure we're happy, there's no negative numbers, excellent. And then the 5th row will be a mess. Let's see here. So we want 15 times row 5 plus 37 times row 2 to become the new row 5. 15 times row 5 plus 37 times row 2. And that did make that into a basic variable. And we don't have any negative numbers over here. So far, so good. All right, do we have any negative indicator variables? Yeah. Yes, we still have one negative indicator, or no, 2 actually. All right, so we have not yet finished solving this problem. All right, so we move forward. First step, most negative indicator variable, which is this one. So we're in this column someplace. All right, so our quotients are the rightmost column divided by these guys. Okay. All right. Again, I highlighted one too many here. There's no negative ones and there's no zeros here, so it's okay. So whichever one of these guys is smallest, which is this one. So this is the row. We already knew this was a column. So this one here is the pivot.
Yeah.
Right? All right.
And then I just didn't get the right answer.
What did you say?
I said then I just didn't get the right answer. I was off by like a weird number from the back of the
All right, well, let's just keep working on these and see what happens here. So how do we get from here to here? It looks to me like we need 105 R1s minus 155 R4s. Is that right? To become row 1. Let me double check that. Equals 105 times row 1 minus 155 times row 4 equals 0. Notice, by the way, I kind of like to do it. I haven't really been doing it very much like this on the examples we're doing. I kind of like to do the column with the pivot because I make sure that's a 0 before I pull it across this whole thing. But it would work either way. It's just that I like to make sure I have a 0 before I copy this whole thing across. All right, row 2. Row 2 is going to be 105 times row 2 minus 10 times row 4 becomes the new row 2. Make sure that's right. 105 times row 2 minus 10 times row 4. And that does give me a 0. That's good. Pull that one across. I'm noticing a pattern as to how these things work, right? 105 times row 3 minus 75 times row 4 becomes the new row 4. Equals 105 times row 3 minus 75 times row 4. Make sure that gives us a 0, and it did. Pull that thing across. Row 4 is just itself, because it's the pivot row. And row 5. 105 times row 5 plus 155 times row 4 becomes the new row 5. 105 times this one plus 155 times this one is a 0. All right. Hallelujah. All right. Oh, no, we still have a negative one. Crap. I thought we were going to do that after.
Oh, that's fine.
All right. Okay. We still have one negative indicator variable down here. So we are still not done. Let's see. But it will be in this column someplace, because it's the most negative indicator variable. Now, this time we will have that little trap. Our quotients can't have had a negative denominator. Isn't that part of the rules, if I remember right? So, let's find out what our quotients are. Minus this one divided by this one. I'm sorry, equals this one divided by this one. Let's pull through here. Alright, so, yeah, I believe it said no negative denominators. Isn't that what on that table? Oh, it's section 4.2 on page 153 that had that giant table. Form the necessary quotient to find the pivot. Disregard any quotients with a 0 or negative number in the denominator. Alright, so we have to throw that one out. So now we're looking for the most negative ones of these. If there are two, there appears to be two that are the same this time. That's weird. Better look for the rule. I think it says use the one highest on the table. If two quotients are equal and smallest, choose the pivot in the row nearest the top. Okay, so it's this one. So that's our pivot. Alright. This is the part of the reason why we make sure that the next test is open book. Because, I mean, who'd remember all those details, right? Alright, so next one. Top one is just row 1. That is the pivot row, so we just take that guy across here. Like that. Oh my word, the numbers are getting big here. The next one is, let's see, 22440 times row 2 minus 3165 times row 1 becomes row 2. Make sure that's right. Gosh darn it, these numbers are getting big. 22440 times this one minus 3165 times this one. Make sure he's a 0 and spread them across there. Alright. Next one, 22440 times row 3 minus 12870 times row 1. Make sure of that. Times this one minus 12870 times this one. See the pattern? I'm just using those values that are in each of those columns to get this. Looks good so far. Got 3 rows. Okay, fourth one. 22440 times row 4 plus 117 times row 1. 22440 times this one. I'm sorry, no, times this one, plus 117 times this one. Well, this is the last pivot on this one. I don't like this one very much at all. Alright, and the last one. 22440 times row 5 plus 1020 times row 1. 22440 times this one plus 1020 times this one. Ooh, B, nope, I'm tired of this one. Let's see if that's it. Hey, alright, thank God. Oh, Lord. So at any number of places along the way here, we could have like divided a row by 1,000 or something like that and got rid of a bunch of these zeros. I was just trying to keep this, I mean, the computer doesn't care, right? How many digits we've got and so on. So yeah, alright. So the question is, did I have this right? We have no more negative indicator variables. That sounds good. Alright, so which are the basic variables? This one's basic. This one's basic. I'm missing the spots a little bit, but that's okay. This one's basic. And this one's basic. So right off the bat, everything that's non-basic is equal to 0. So x2 equals x3. Here, let's just make ourselves a little table here. x1, x2, x3, x4, and x5. Alright, and we see that x2 and x4 are non-basic, so we know those guys are zeros. Alright, when it gets time then to pick out x1, it's going to be this number of times x1 plus, well, this we don't care, 0. 0 times x2 times x3, 0 times x4, 0 times x5, 0 times this, 0 times this. It ends up being just this number divided by this number. Oops. Equals this number divided by this number. 108. Anybody happen to look in the back of the book? Is that the right answer for this one?
Yeah.
Haha, alright.
I'm still trying to copy down your math.
Oh yeah, that's no problem. But
Can you like extend row A out just so you can see better?
oh, so you can see better?
Yeah. Thank you.
Yep. Makes sense. Alright. Well, I'm going to share this one with you. And then I'll give you guys a chance to work on this and like send it to me again if you want. Because here's the deal. Again, we're building on this. Alright? Hey, here's x3. It's going to be 0 times x1, 0 times x2, something big times x3, 0 times x4, 0 times x5, all the way equals this thing divided by this thing to get x. And you got 454. And people who looked in the back of the book, was that the right answer?
Yes.
Alright. And x5. It's this one. Okay, so it's this giant number divided by this giant number, and you get some weird thing. 1365 or 1363?
Yeah.
Alright. Hallelujah. And for that matter, what is our objective function? It's going to be the same sort of thing. It's going to be 0 times this times 0 times this plus 0 times this. It's going to be equals this one divided by this one. And your objective function is like 70,000 something?
Yeah.
Ah, right. Excellent. Let me thin this stuff out here. Because these guys don't need to have highlighting. I'm stretching too far. There we go. Alright. Hey, that was one with 5 variables and 4 constraints. That in and of itself is a big problem. Okay? And they get so much bigger in the real world. But in the real world, you wouldn't be sitting here doing this on a spreadsheet. In the real world, this would be an application or something like that that is making these decisions. But this is what it's doing. And plenty of real life problems would be benefited if we could do these. It would be a benefit if they could do them. Woo! Allow me to share this with you. File, share. I'm going to turn off editing. And share it with Malia. How come I don't have you here? What is the address that you like? Matt, this one right here.
Yeah.
There you go. And Haley, and Andrew, and Luke, and Lisa, and Sierra. Here is the key for number 17 on page 158. You can finish this problem up and get it to me by Wednesday. Okay? Hey, before we go into new material, are you sure? Yes, I'm sure. Before we get farther on that, I want to talk about Wednesday. Wednesday, you guys are having a pop quiz. Okay, which doesn't really make it pop, right? Obviously. All right, you're having a pop quiz. It has one problem. It is a standard maximization problem, like what you did in this homework set. It's not a very big problem. It doesn't have like zillions of numbers like this, and it doesn't take a ton of pivots to do it. Okay? It is not a problem that's in your book. It looks a lot like a problem that's in your book, but it is already, it changes the numbers in it. So like, don't think, oh, it's an open book, I'll just find this one because he's too lazy to have made a new problem. No, I did make a new problem, okay? So on Wednesday, you're going to have a chance, there'll be a problem, I'll send it to you guys, and you'll do it in a spreadsheet, share the spreadsheet. If you'd rather do it on paper for some demented reason, you know, you like paper better than, or whatever, that's fine, we can do that too. But you do have like a little pop quiz making sure that you can do these guys. Now, what's weird about Wednesday, you might have heard through the grapevine, hell damn crap, I drew jury duty again. It's like the third time. Anyway, so Tuesday night I have to call the courthouse and find out if I have to report on Wednesday morning. So I won't know until like 7 o'clock at night on, because you know, like you draw jury duty, but obviously at the last minute, like 90% of court cases settle, right? They don't actually want to go and sit. Odds are it's not to anybody's benefit to actually be in front of a jury where a jury could do any damn thing it wants, right? So most of the time they settle. And so hopefully people are sorting their problems out and I don't have to go to jury duty on Wednesday morning. But if I do, obviously there'll either be a substitute or Mrs. McNamara will come down here or something since it's just you guys taking a pop quiz or whatever. Now, there is new material on Wednesday. I already have the PowerPoint put together. What I'm going to do probably is like record it. Okay? Like do a screen capture thing where you can hear me and watch it on YouTube. It won't be like this with video. It'll be you're seeing the PowerPoint, just hearing my voice. It'll just be a simpler way of making it. So if you guys do have the pop quiz and I'm in jury duty, what will happen is you can go and just watch that lecture on your own time on YouTube or whatever when you're done with the pop quiz. It probably would make sense for you to go in the comments and just do it then since you're already here. But that's up to you. Okay? But probably, being as this is like my third time in jury duty and I've never yet actually had to go down to the courthouse, I've had to do it before in other places that I've done, but never here. Hopefully I'll just be here and we'll just have class as normal. Okay? I think I have written down that you'll have up to 30 minutes to take the pop quiz. That's just one problem. What it is it's one problem, but getting the right answer isn't like the be-all, end-all. Because then there's like 9 questions on there that are like, explain how you did it. How did you know it was time to stop? Oh, because all the indicator variables went positive. How did you know how did you find the first pivot variable? That kind of thing, okay? So there's ways to get, I mean, getting the actual final answer is not the entire, you know, it isn't like, well, it's all or nothing. No, you get points by finding out, showing that you know what you're doing, okay?
Can we please go over number 10? I just don't
Sure,
understand.
why don't we
I think
do
it's
number
the-
10?
The decimals are throwing me off.
Yep.
Do we have school, or do we have this class on Friday?
You know what? I'm not sure. Let's figure that out real quick. Because I have them all in my official calendar. Let me look real quick. I think we do have this class on Friday.
Because we had 2 in a row.
Yeah, that's why I want to make 100% certain about it. My calendar says that is an early day, and this is an early day. Okay, so yes, I think so. All right. So, Malia wants to talk about number 10.
Never mind.
Are you sure?
Never mind. Never mind the never mind. I was being like I was reading 21 as 12, but then it did have 21, but I read it in my mind.
Okay,
as
so
12.
you're okay right now?
No.
You want to do it?
Yes.
All right. Then what I'm going to do is I'm going to close this one up, and we'll go back over here to finite. Where did it go? Finite math, keys. Where's keys? Key for homework 12. Okay, so we already got that one. Let's go ahead and make another spreadsheet. We'll call this one problem 10, and I'll gladly share it with you because I want you guys to know how to do these things. Problem 10 on page, what are we on here, 157? All right. Problem 10, you got an objective function and you've got two constraints right there. So this is not going to be too big of a matrix here. It's going to have two slack variables. There's always one slack variable for each of the constraints. All right. So our first row, which was 2.8, 3.4 slack, and the last thing there is a 21. And then the next one, 1.4, 2.2, here's that other slack variable, and it's an 11. And then we got to move everybody over on the objective function to the other side. So it's negative 1.5, negative 4.2, nothing, nothing, 1, nothing. All right, so that's our initial tableau. And of course, it is not yet optimized. It's a feasible solution. We could pick the solution off here. I think it turns out to be that x1 equals x2 equals 0. Well, it's a feasible solution that does satisfy all the constraints, but does not yet actually maximize that function. So we got to find our pivot. All right, we find the pivot by the column with the most negative indicator variable, which is this one. All right, so that's where we're going to use to find our quotients. The quotients are the rightmost column divided by these guys. Alright. So it's one of these two columns. It's the, okay, neither of, I guess I can pull this out of here. Neither of these guys here is negative or 0 or anything, so we're fine. So it's the lowest one of these, so it's this column makes this guy the pivot. Alright, so how are we going to pivot these guys? For row 1, looks like it's going to be 2.2 times row 1 minus 3.4 times row 2 becomes the new row 1. Hey, where are we at? There. So let's see if that works. 2.2 times row 1 minus 3.4 times row 2. Make sure that that is equal to 0, and it is. Pull it all across. Happy. Didn't get a negative number in the rightmost column. What?
I don't know.
Oh, Malia's not sure.
I did. Okay.
Alright, row 2 doesn't change, because it's the row with pivot. And row 3. Row 3 is going to be 2.2 times row 4 plus 4.2 times row 2 to become the new row 3. I'm sorry, I wrote row 4, but it's row 3. Make sure that works. 2.2 times row 3 plus 4.2 times the pivot. Oh, does give me a 0. Stretch it across, didn't need any negative there. Okay. Now, we only did one pivot here, but notice what happened. Here's our indicator variables. We've got no negative indicator variables on this one. So, we are at a optimal solution. Now, so let's find our solution here. Okay, so here is a basic variable, and here is a basic variable. So, if we were picking off just the x1 and the x2, we already know that the x2 being the x1 being non-basic is 0. And x2, well, we could just divide that row through by 2.2, or go over here and just pick 11 divided by 2.2, and you get 5. Oh, this answer is in the back of the book, is it? All right. So, and then the z. The z is going to be, the z is going to be equal to this column divided by this one. Hey, wait a minute. This one we could have solved. Oh man, do we have time for that? Sure, what the hell. I'll just talk faster. Anyway, this one only had 2 variables. We could have done this one graphically. Right? Let's actually check that one out. Linear programming using Desmos. Whoa, sorry. Des books, there it is. I want to show you guys something that some of you have already discovered on your own. That's why we're really doing this here. Okay, now, as far as I can tell, Desmos has no idea about, like, if we wanted to call these variables x1 and x2. As far as I know, you have to be x's and y's. Has anyone found differently? As far as I can tell, there is no way to change that. Alright, so we have to be a little bit careful here. But like on this one, we could call this 2.8x plus 3.4y, because they don't have x2, is less than or equal to 21. Okay, we're just having to be, we have to have faith here about this x's and y's instead of x1s and x2. Alright, now, 1.4x plus 2.2y is less than or equal to 11. Ooh, are they really that close? Yes, they are. Alright, so here we have our feasible area. Of course, we also have this possibility, we also have to have that x is greater than 0 and y is greater than 0, but can we all agree that it's this corner right here, right? Alright, so we now know our feasible region. Now, some of you have already discovered a nifty trick. We can actually insert onto here a little table where it'll compute the z's for us at each of those points. You go over here to this plus, and say you want to add a table. Now, we can pick these values off of here. Now, it's probably somehow possible to get these points, drag them over here, but I haven't figured out how to do that yet. Don't get me wrong, I'd be actually kind of surprised if you can't. But right now, I've just been putting them in myself. 0 and 5. And this point right here is 6.2861. 6.2861. And this corner down here is 7.50. 7.50. So now we have those three coordinates. And see now they're all lit up because we've entered that table right here. Now if you just add another column here, it'll gladly let you keep typing. Put the objective function there. 1.5 x1 plus 4.2 y1. You have to use the names it's using on these columns right here. But notice, hold on, let's go back over here. Okay, we're looking for the maximum. Here's the maximum right here. Right, of these numbers here, here's the maximum, and it's at 0.5. Alright, and we can go back over here, see what we have. At 0.5, we had a maximum of 21. And look how neat that is. Now, if you actually zoom this out, by the way, for some strange reason it decides to actually plot the z's on the graph here, but that isn't actually a helpful thing. But if you just click on this, it turns them off. That can be a problem if they're like way far off the graph or something like that. Anyway, so like just sending me this one, screenshot this and send it to me, that would be brilliant. I'd be excited about that. So, that's a pretty neat trick if you wanted to do that. Malia, tell me how you feel about that. Oh, good. All right. Tell you what, let's cover some new material. All right? Yeah, MJ. Yes. So we'll let MJ go for a minute, and we'll see if we can think of something to talk about for just a minute or two while she's using the restroom.
Talk about the weather.
What did you say?
You can talk about the weather.
We can talk about the weather. After all the heat this September, what did you guys do this weekend? My 8-year-old is a Cub Scout, and this was Popcorn Blitz weekend for their fundraiser. So he had to stand outside of Party City out on Burkhart Road and try to sell popcorn in the rain. And every year when he's selling popcorn, we shoot a little video of him selling popcorn to put on Facebook so that, because you can sell popcorn on Facebook too. And I was trying so hard to get a video of him out there working his butt off in driving rain trying to sell popcorn. But I didn't get any good footage of it. So unfortunately we'll have to get a good video of him making people feel sorry for him that he's out there selling popcorn in the rain. He ended up only selling $85 worth of popcorn out there in the rain. It's tough. Popcorn is not one of your foods you're thinking of when it's soggy out, you know?
And I'm like, oh, I really want.
I know,
I'm gonna go out in the rain.
I'm gonna go out in the rain and have, I was like, man, you gotta be selling chili or something like that out here in this. But anyway, so that boy, he can really sell. When you get him, I don't know where he got it, because I don't speak to strangers, in case you didn't. In case you haven't figured it out, Andrew. If I ran into you outside of this classroom, I wouldn't remember who you are. I'm just not good at that. It's a mental illness. I don't recognize faces. But my gosh, my little kid, he can just walk up to you and he comes up and he says, "Hi, my name is Xavier and I'm a Cub Scout. Would you like to support Scouts by buying some popcorn?" And he's got 4 teeth missing on the top and 1 on the bottom, and it looks like he plays hockey. And they just can't resist him. Except in driving rain. In driving rain, they walk right past him. So we were out there in the rain most of the afternoon, trying to get people to buy popcorn.
I had band competition and it was indoors. We got 3rd place, but I'm not shocked anymore, and I'm just ready for the season to be over.
What do you play?
I'm in the color guard.
Oh, yeah, that's right, you're in the color guard.
I can play the flute, but I had jaw surgery and now I can't make a noise on it.
That's interesting. Yeah. I used to hate band competitions when I was in high school. I liked being in the band. I didn't like. I was like, what's the point of a competition?
And like
I am in no control of what those clarinetists are doing. You know what I'm saying? I mean, I guess that's how team sports work, but you know what I'm saying?
Just a bad program right at the moment.
What did you say?
It's just a bad program right now.
Oh, it's a bad program.
Like, it's not like that we're like actually, we're pretty bad, but it's just not handled, the staffing, it's just not handled the best.
That's what Rhiannon
And like 5
said.
people quit.
Yes, Rhiannon quit.
One
And she's done color guard since freshman year because it was that
And I was
bad.
really hoping that her sister Caroline would quit, because if Caroline quit, then I could have quit, and it would have all been fine.
Wow.
Like, even the staff, like, the
But
staff
isn't it-
has like
it's
come up to
Caroline's
me.
first year doing it, isn't it?
It's her second, yeah.
That's
And then
right.
she like was crying, and like the staff members were crying to me, and they're like, "I want to quit. I don't even want to be here." And I'm like, "This is the problem."
This might be an
We don't
excellent
wanna
time
be
for
here,
the
we
people
don't
who are
wanna
watching
be
this
here."
on video, by the way. If you didn't already know on
no.
YouTube, if you're watching, like, for example, if I have jury duty on Wednesday and you're watching Wednesday's lecture on YouTube, anytime you're watching anything on YouTube, do you guys know that you can, like, hop around in the video with keyboard shortcuts? The most important one when you are trying to learn something from YouTube is J. J rewinds it, I don't know, 10 seconds, 15 seconds, or something like that. So if you're watching a video, you're like, whoa, 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 what did you just say? Tap J a couple times and we'll rewind it like a minute.
Yeah, the
You know.
arrow key goes back 5 seconds.
What did you say?
Arrow keys go back.
Arrow go back. Oh, I didn't know the arrow keys did anything. That's interesting. So if you're watching it, and then I think it's K. Like if you're sitting there, whoa, why is he wasting my time with this? I think it's K. Hops you forward, but apparently arrow keys would probably do that too.
Yeah, same thing.
Yeah, so like if you're sitting there right now watching us have this conversation about the color guard, you might be sitting there tapping on that arrow key.
How about we try it this Saturday?
I don't know. When I was teaching online classes, there was always this big, like a window would pop up that had the video of me teaching, and then below it, it had, if you know, press. It was an image that was always there that said press J to rewind by 15 seconds or whatever it is. Because that way, I mean, because YouTube's controls are a little bit fussy. You know what I'm saying? Like, if you just want to, whoa, what did he say? I want to back up a minute. If you think you're going to like move that little slider a little bit, it's actually kind of hard. Whereas just tap on J and you're back 30 seconds or something. It's kind of the way to do it. Yeah, so you might end up having to watch the non-standard problems lecture using YouTube because it just might not be. I may have to go to the stupid jury meeting. Makes me mad. How is this possible? The 3rd time already.
Well, 3rd time's the charm.
No, and I don't want to do it. All right, so we're moving on to section 4.3 now. And here's the deal. Everything that we've done so far, all these linear programming problems that we did in chapter 3, and how we set them up in graphic form and so on, and we learned how to do them using the simplex method, have all been the so-called standard maximization form. And it's become so ingrained in you, it's going to take a little bit of practice to notice when they're not in that form. Remember, this was when the objective function is being maximized, like z is equal to profit or something like that. And all the variables had to be non-negative, and all the remaining constants are in the form of like something x plus something y plus something was less than something. You know, like we couldn't use more than the amount of flour we had and more than the amount of sugar we had and so on. These were their standard maximization form, but in fact there are other forms that are perfectly good and useful. And the one that we're spending time on today, that was just a screenshot right from the presentation on last week sometime. Is the one that we're spending time on today is called standard minimum form or standard minimization form, but that's harder to spell. And unsurprisingly, a standard minimization form problem is when you're trying to minimize some objective function. Now, when we mean minimize, like we're trying to minimize cost or something like that. Like our objective function, we're trying to find the combination of things that we can do that are minimum. Now, if you stop and think about that for a minute, you're going, the answer is always going to be 0 and 0, but the constraints are usually the other way around. Like you have to make at least so many cupcakes and at least so many cakes. In other words, like our constraints are going to be greater than, like this much, we have to use at least this much material or something like that. Where we have this plus this plus this, that has to be greater than some constraint. These are going to be like, remember when we were doing them graphically and we talked about bounded and unbounded? These are going to be like the unbounded problems. Where, oh, I mean, you certainly could. A feasible solution is make 1,000,000 cookies and make 1,000,000 cupcakes and make 1,000,000 pies, but then you're not minimizing your cost, right? The question is, what's the least you can make and still satisfy all these conditions? Now, when you take a little look at this here, then there's two main things that we're catching here. This idea that we are minimizing the problem, the objective function, and our constraints are the other way around. We want, instead of being we can't use as much as this, now it's we have to use at least this. But there is a sneaky thing in here that makes me a little uncomfortable. Your book decided, somewhere along the way, when it's a minimum form type problem, instead of using x's, use y's. Yeah, see the eraser's coming out. That's just a notation thing. I have no idea if George Danzig got a Nobel Prize and he did it that way too, or if that's the book thinking it's helping you. Now, in practice, how they're going to show you how to do this, it's actually pretty neat. So when the problem is written in minimum form, using y's for these variables, like y1 might be the number of cupcakes to make, y2 is the number of cookies to make, and y3 is the number of pies to make, is okay. Because we're going to change it anyway. We're going to use a property that he discovered, or somebody discovered after him, called duality, to change our standard minimum problem. Here's the deal. The simplex method can't solve standard minimum problems. But we can use a mathematical property called duality to change the standard minimum problem into a related standard maximum problem, where we're going to be able to flip all those inequalities, and we're going to change it from minimizing a function to maximizing, and then we can use the simplex method. This is a weird bit of mathematical theory that we won't bother trying to prove or anything like that, but this idea of duality is pretty neat. It is proven that the solution of any standard maximum problem produces the solution of any associated standard minimization problem, and vice versa. In other words, flip back to section 4.2. Every single one of those problems was a maximize problem. Maximize z equals this, given x plus 1 was less than this. And every one of those is a maximization problem. But after today, you're going to find out every single one of those could have been flipped into a minimization problem. And every single place where you find a minimization problem, it could be flipped through this idea of duality into a maximization problem. There's always a one-to-one match like that. Every max problem has a min problem. Every min problem has a corresponding max problem. That is called duality. And as it happens, the simplex method can only solve the max problems. So what you do if you have a minimum problem is you use this property of duality to flip it into a maximization problem and then use that simplex method to do it. The good news is open book. By the way, duality and minimization problems are not on the pop quiz on Wednesday. It's a max problem. It's purely a thing of demonstrating the simplex method. Okay? But you're going to have to do it to do this homework set too. All right. We love this because we now have a powerful tool, the simplex method, to solve these max problems. So let's actually try this here. Here is a problem that seems perfectly reasonable. Minimize this objective function. Now we're going to use the symbol W here instead of Z, because when we flip it into a max problem, it's going to become a Z. All right, but we're not there yet. So we're minimizing this thing, given this. By the way, notice there's only two variables, y1 and y2. We could do this in Desmos, using linear programming. In fact, we will, if I remember right. I made this PowerPoint about 2 weeks ago, so we have to make sure we're good about this. But I'm pretty sure I do. Alright, perfectly reasonable. We got to make sure that whatever we come up with a solution, y1 plus 5y2 is greater than 9, and this many y2 plus is greater than 10, whatever. Alright. Again, we're going to have a set of steps in one of those green boxes in section 4.3. But what you're going to do, forget about slack variables and all that good stuff for a moment here. Go ahead and just write the matrix as we have it right now. I mean, we've written systems of equations as a matrix before, right? I mean, 1y1 plus 5y2, we're going to head towards equals 9. 2y1 plus 2y2 equals 10. 8y1 plus 16y2 equals 0. Alright, we're going to write it out for now. Again, I'm going to post this for you if I haven't already and all that good stuff. I'll double check on that. So you can have this PowerPoint and all that. Alright, now, what I need for you to do, again, you're going to see this in just a little bit on the instructions. Then you take that system of equations that you set up, that matrix there, and you're going to do the business of transpose it. Now, transpose is something that we learned about way back in the matrix section. We did it, for example, when we did all that graphic stuff about the ghost. Transpose means change rows into columns and columns into rows. So, row 1 becomes column 1. Row 2 becomes column 2. And row 3 becomes column 3. Transpose is a powerful tool for lots of different things in matrices. Here we're doing it, though, just on this augmented matrix that represents that system of equations. Again, we're going to have a set of steps here. I'm just walking through one first. So what we're going to do here is we're going to transpose the matrix that we set up. And we're going to say, hey, this new matrix, this could be a way of saying a standard maximization problem. I mean, this could have been like our x1s, this could have been our x2s, this could have been the other side of the inequalities or so on. In fact, we're pretty good at that. If this had been a standard maximization problem, this would have been the little matrix that we made for 1x1 plus 2x2 is less than or equal to 8. And this would have been 5x1 plus 2x2 is less than or equal to 16. And this would have just meant that they're positive. And the function we were trying to maximize would have been 9x1 plus 10x2 is equal to 0. Is equal to z. So by doing this transpose, and then saying, let's have a little faith here, let's make ourselves the maximization problem that transpose would have meant, we have set up the dual problem. This problem, and the one that's kind of grayed out here, aren't the same problem. I don't want you to say that like the minimization problem is equal to the maximum problem, but they match. See? See how this problem came from this one. We wrote it as a matrix, we transposed the matrix, and then we said, what is this matrix, what would that look like? They're not equal to each other, but they do match. There's a one-to-one match. Only this problem could have given us this one, or only this problem could have given us this one. They are duals, to use the right word. Well, now that we have this is a friend. We know how to solve this guy. That's what we did in section 4.2. That's just the simplex method. All we would do is take this known problem that now we've set up, and we would take all those 9 steps or whatever it was back in section 4.2 that now we're getting good at, and we would say, okay, well, first I got to change those guys from inequalities into equations by adding slack variables. So x1 plus 2x2 is less than 8 becomes x1 plus x2 plus 2x2 plus some slack equals 8. And we would do the same thing for that second inequality. Right? And then we would set up our friend, the simplex tableau. Right? 1x1 plus 2x2 plus 1 times s1 plus 0 is 8. And do that for each of those variables. Over here for the bottom row, make sure you drag everything over to the same side as z, and you're happy. And then we would start using our simplex method to start solving this tableau. And so, alright, it's a standard maximization problem. We take our simplex tableau and we perform the pivots. Now to save time, I'm not going to do all the pivots because in this particular example that came from the book, it takes 3 pivots, which is, a good 10 minutes, and we don't have it. So in this case, it took 3 pivots to do it, but we eventually got to a place where I know that this must be the answer because I have no negative indicator variables. So this is the simplex tableau that tells us the answer for that dual problem. The maximization problem that is related to the minimization problem. We could read our standard maximization problem solution off this tableau. We would look for the basic variables and so on. But that's not, I don't care about that. I just needed this tableau. Once I have this tableau, I need to double check to make sure that the entry for z here is a 1. If it is not, divide through by what you need to make that happen. It's like if this has been a 5, then divide through this row by 5. That's fine, that's just a row operation, that doesn't hurt anything. Okay, we would just divide through by 5 to make it happen. But, once I've done that, these 2 variables that are under the slack variables are the values of y1 and y2. They are the variables that we were trying to solve for. In our standard minimum problem, we were trying to find values of y1 and y2 that minimized that objective function w. So in this case, slack 1 is y1, slack 2 is y2. Those are the values that produce the minimum answer. So they're lurking there on the tableau. We don't need to go look for basic variables and all that kind of good stuff. I mean, that's all really interesting and useful, but not what we need right now. Right now, the answers we needed for our minimum problem are lurking there at the bottom of the slack variable columns. And for that matter, the bottom right corner down here, this value here, that is the value of w when you use this for y1 and this for y2. So see what happened here. We started with a minimum problem. Simplex methods can't solve that. But then we use this property of duality to say every minimum problem maps to a maximum problem. God, I shudder to wonder what the proof for that looks like. but it exists. Somebody got a prize or something for proving that. Well, once you have that that maximum problem, now simplex method works like great for this. Do it, and your answer will be at the bottom of the slack columns, and the answer for W, which we're trying to minimize, is over here. So we have a set of, hold on, I guess I don't have it. I thought I had made this one a graph. That's okay. So we have this set of rules for these guys as to how to solve them. You write it out as a minimum problem, and then you say, I'm going to use that series of steps to find the dual problem that matches it. We started with a minimum problem, so there's a maximum problem that goes with it. Once you have that, just solve that maximum problem using the simplex method. Yes, I realize step 2 really means 9 steps over there on a different page, someplace in section 4.2, but you've gotten a lot of practice doing that. Once you have that, the minimum value of the function, that W that we're looking for, it is that max value of Z. It's that bottom right corner. And the solution to the minimization problem is the entries at the bottom row of the columns for the slack variables. That is pretty slick. A technique that we've already been practicing can be co-opted. We can take these minimization problems, which can't be solved using the simplex method, but take and use the property of duality to map it out. Let's do one. I like this problem about it's golden retrievers in the book. We used to rescue golden retrievers at our house. Now we have kids. We don't have time for big old dogs. What? Gotta sell popcorn. No kidding. Although we had a little dog. If we had a dog with us, that would even be better when we're trying to sell popcorn.
Wait. This is the other way around.
Kids shed less. Golden retrievers, oh my
Yeah,
gosh.
but like if you're going and you see a dog, you're going, I'm gonna buy popcorn.
Oh,
I'm
man,
not
we-
in the rain.
Kids.
We used to rescue them. They were something. Okay, we got 10 minutes. Dog breeder needs at least 10 okay, to serve the dog, they need at least 6 units of some nutrient A and at least 3 units of nutrient B for her dogs, and the breeder can choose between 2 different feeds, feed 1 and feed 2. Find the minimum cost to the breeder if each bag of feed 1 costs $3 and each unit has 1 unit of A and 2 units of B, while each bag of feed 2 costs $2 and provides 3 units of A and 1 of B. Okay, that is a whole thing to be parsed out. So here, let's kind of walk through this one, and again, because we're taping it and so on, you can catch this later if you need to. Basically, what we're trying to solve for is Y1, how many bags of feed 1, Y2, how many bags of feed 2 do we need, and we want to minimize the cost. Y1, bag feed 1 costs $3, feed 2 costs $2, so we're trying to minimize the cost, and here's the cost, $3 for each bag of this and $2 for each bag of that. Alright. The dogs need at least 6 units of A and at least 3 units of B. Alright, so here's how much nutrient A we get, here's how much nutrient B we get from each of the 2 different kinds. Alright, this looks like a minimization problem. We're trying to minimize the costs and notice the constraints. Sounds like the minimizing cost would be buy no dog food. I can tell you golden retrievers don't like that answer. They don't like the answer either when the dog food is mostly ground up Chinese newspapers. That was always a running joke in our house, that the cheap food was just mostly ground up Chinese newspapers. Very little nutrition in this, our dogs are looking at us. Alright, so they gotta have at least 3 units of each of those and 6 of that. Alright, so our steps say we gotta change this into a dual, use the property of duality to find the corresponding max problem. So we start by writing the augmented matrix. Alright. This is the same thing as saying 1 times this plus 3 times this equals 6. 2 times this plus 1 times this equals 3. And 3 times this, 2 times this. Again, the steps are written out very carefully in section 4.3. Then they say, take that matrix and transpose it. So I flipped it. Row 1 became column 1. Row 2 became column 2. Row 3 became column 3. And once you've done that, use that new matrix to write what is the maximization problem that this matrix means. And if you pick it off of there, I notice I changed a purpley background here, it becomes this maximization problem. 1 times x, notice it becomes x's by the way, because it's a max problem now. 1 times this plus 2 times this is less than 3. 3 times this plus 1 times this equals 2, and the max of z when it's 3x21 plus 3x2. All we need is, hey, what would the problem be? If that was the matrix, what would the problem be? Alright. Well, we could solve the heck out of that now using our simplex method. We can take it and say, oh, I see. This means this plus some slack equals 3. This plus some slack equals 2. And set up the tableau. Here's our tableau. I mean, it has a perfectly feasible solution up here on our initial tableau. No bags of feed 1. Oh, well, wait a minute. We don't exactly know what this is doing yet. Alright. And then we... Oh, good. I've actually walked through all of this. Let's actually look real quick how we would do this. We find... Oh, I see. We already had... Okay, so I skipped all the steps here where I did the pivots and stuff like that. Alright, no problem. So, alright, we checked, we made sure that the bottom row had a 1 in the z column. That's good. If not, we would have divided by whatever it took to make that happen. And that means that these two values that are down here in the slack columns are y1 and y2. These are the answers lurking here on the table. So y1 and y2 should be equal to that. Now, let's double look, check here. Does this work? Are the dogs getting at least 6 units of nutrient A? You plug it in, and they get 6. That's good. Is it working out that they get 3 units of vitamin B or whatever? You plug it in, y1 is equal to this, and well, they get at least 3. Okay, good, yeah, Andrew.
So if z was 2, would you divide the bottom row by...
By 2 to get rid of it?
By
Yep.
2? Okay.
Very good. Alright. And this, in theory, is the minimum cost here, whatever 27 fifths is. Well, in this particular case, because there was only 2 variables, we could actually go ahead and just do the simplex method. Graphical method here. We could actually go ahead and graph those inequalities, find our corners here, make ourselves a little table and find out, oh look, at this one here, here's our minimum cost, and we get, whatever that is, that's the same number that's just written as decimals. Excuse me, I have the hiccups. Neat. So these numbers here are the solution for y. It looks like we got the right number using that method of duals. Alright, so here is your problem set for today. It is not a ton. In fact, I think these problems are just practicing making a transpose. And these problems say, write the problem out. It does not say solve it. So I'm thinking you might have as few as 3 actual minimization problems. And I think 9 and 10 are just, it gives you equations. And I think number 19 is an actual story problem. Alright, there is a little exit ticket for today. I apologize that everything ran a little bit late, but we kind of had a weird day. So you should have, let's just double check. If you go to Stratocumulus, hopefully you have that bookmarked or whatever, you should have in Finite Math for Monday the 24th, here's an exit ticket. And yes. It's mostly word type problems. Alright, let me stop the camera. And while you guys get started with that, I'm going to haul the camera upstairs.